Hello once again, awesome scholars. We are going to continue our discussion of the heart by looking at some different heart problems, actually when the heart breaks. So, 3 common problems with the heart include cardiovascular disease, CVD, hypertension, commonly known as high blood pressure, and then arteriosclerosis, which is plaque buildup in the vessels. So we're going to start with cardiovascular disease. We find that CVD kills more people than cancer each year. Yes, CVD kills more people than cancer each year. Let's put this into perspective. Of all the different types of cancers that are affecting many people every year, cardiovascular disease still kills more people than all cancers combined. It is actually the #1 killer in the United States. In 2006, approximately 9 years ago, over 800,000 people died from CVD. Cardiovascular disease represents 34% of all death in the United States. So imagine you and 2 classmates are sitting at one of the tables in class. You look to your left and to your right. If they do not die, you will die. Because remember, 34% represents 1 in 3 people. Now, what is even more alarming is that over 80 million people currently living in the United States now have cardiovascular disease. Now, the diseases of the cardiovascular system include the heart attack, high blood pressure, arteriosclerosis, stroke, and heart failure. Now, while I was away, you had an opportunity to explore one of these diseases through a PowerPoint, and I do hope that you gained a lot of information from your research. So, let's look at the heart attack. The heart attack is scientifically known as a myocardial infarction. Now, myo means muscle, cardio refers to heart, and fart refers to death. So basically, dead heart muscle. Now, the heart attack occurs when blood is blocked from entering the heart. And when we have this blockage of blood from the heart, it's called ischemia. Because what happens is, as you see here in this brown portion here, this represents the heart tissue that is damaged due to a lack of blood flow. And you look at the blow up, if you will, here, you see where there's plaque buildup right here in the artery, which helps to prevent blood flow. And so when there is no oxygen getting to the heart tissue becomes damaged, and that is what leads to the heart attack. And we refer to the lack of blood flow as hypoxia. So again, hypoxia is lack of blood flow. This is a picture of a diseased heart, and we will discuss it more in detail in class, but I at least wanted you to have a look at what the inside of a heart, or how the inside of a heart looks once it has become damaged. Okay. So, what are the causes of a heart attack? Well, arteriosclerosis. Remember, we talked about that being the buildup of fatty tissue in the vessels, and the fatty tissue is called plaque. And the different causes of this include cholesterol and fatty or fried foods. Now, let me explain something to you. All cholesterol is not bad. Now, the body synthesizes some cholesterol on its own, and then the other cholesterol we actually ingest from the foods that we eat. Now, cholesterol is very important as it is the backbone of our different steroid hormones in our body. However, we do not need as much cholesterol as we consume. Now, let's take a few moments to look at this nutrition facts label. I want to highlight a couple of things before we get started. Notice that the serving size here says 6 ounces. and there are 25 servings per container. Now, I'm not sure what this food is, but this label just came from the internet randomly, and I found it and said, let me discuss this with my students so we can put this into perspective. So you look at it, this 6 ounces represents a very, very, very small portion size. You know those little bitty cans of soda that you get that are 8 ounces? Take away 2 ounces of that and you have about the amount that I want you to kind of think about. Think about a size maybe like a little bigger than a deck of cards. So very small serving. And in this food, there are 25 servings. So suppose you ate the entire container of whatever this is. That means that you would get 690 calories times 25. Because remember, everything in this label here is found in only 6 ounces. And there are 25 6-ounce servings in this particular food item. So if you ate the entire container, you would get 700 calories. What is even more alarming is that, if you ate the entire container, you get 700 times 25 calories. If you ate the entire container, you would get 126 milligrams of cholesterol times 25. Now, you only need 250 to 300 milligrams of cholesterol per day. Again, you only need 250 to 300 milligrams of cholesterol in any given day. Eating one small 6-ounce serving of this food already gives you about half of what you need. So just imagine how much cholesterol you would consume if you ate the entire amount of food. Let's look at the sodium here. 408 milligrams of sodium in one 6-ounce serving. So if you take the 408 and multiply by 25, you would see just how much in excess of sodium you'll be getting in your body. Now, you only need about 1,500 milligrams of sodium per day. Now, we eat way too much sodium on a daily basis. If you look at any foods in your cabinets, even some of your soft drinks, they are full of sodium. So next time you actually are eating something, check out the nutrition facts label and actually see how much you're getting. And you see here you have 109 grams of carbs, 27 grams of which is sugar. And we talked about the importance of sugar when we did the chicken egg lab. And then actually see here we have 43 grams of protein. So this food is an excellent source of protein, but is not the healthiest food. So if you ever find whatever this is run across this label, children, my scholars, my awesome scholars, please do not eat this food. All right, so let's kind of look at some of these vessels here. Now, this is an artery. It's a cross section of the artery, so you actually can kind of see through it. This area right here in the middle is called the lumen, L-U-M-E-N, which is basically the opening of the vessel. And this is the muscular wall right here. You see it's fairly thick right there. So this area I'm highlighting is like the muscular wall of the artery. Now, if you notice here, there's a tear in the artery wall right there, which actually starts all of the problems and issues. Now, through this tear, we have all this fatty tissue to be deposited. And over time, what happens is the fatty tissue will narrow the artery. And so what happens is as blood is flowing through, it will then clot up because it really doesn't have much more room to go. And so once the blood clots up in the artery is then blocked. And remember, we just talked about it. Arterial blockage will lead to a heart attack and even to a stroke if there's blockage of blood to the actual brain. Now, this narrowed vessel here leads to higher blood pressure. Because you think about it, think about a garden hose. If water is flowing through a garden hose, if you actually squeeze it, the water will shoot out a little bit faster. And so, because what happens is there's increased pressure inside of it. So, with a narrowing of the arterial lumen, the opening, blood flow will be faster, and so there'll be increased pressure. And upon increased pressure, that lets the physician know that there must be something going wrong with your heart or in your cardiovascular system. So hypertension, which I just mentioned, is the scientific name for high blood pressure. And hypertension is actually the silent killer. And it means we have too much pressure in our vessels. And causes include heart problems, blockages in vessels, stress, and your diet, consuming too much sodium, cholesterol, or caffeine. Now, normal blood pressure is 120 over 80. So normal blood pressure is 120 over 80. The top number, which is the 120, represents what we call systolic pressure, where the heart is contracting, and the 80, the bottom number, represents diastolic pressure, where the heart is relaxing. So again, normal blood pressure is 120 over 80. The 120 represents systolic heart contractions. The 80 represents diastolic heart relaxation. Now, as long as your blood pressure is maintained in a range of 120 to 139 on the top, or 80 to 90 on the bottom, then your physician or your healthcare provider is not too concerned. When the number on top exceeds 139 and the number on bottom exceeds about 90, that's when they become a bit concerned, because you're now leading into the possibility of developing hypertension. Right. So now on to our geek of the week, Dr. Robert Jarvik. Now, he was born in 1946 in Michigan, and he attended medical school in Italy, and then he dropped out. But before this, he was rejected by 12 medical schools here in the United States. So he made 13 attempts to earn a medical degree before he finally earned it while working as a research assistant at the University of Utah. So as you can see, there is some hope for all of us who have that persistence and who persevere to the end. Now, what is important about Dr. Jarvik? Dr. Jarvik actually developed what's called the Jarvik 7, which is the very first totally artificial heart. Now, this is the human heart here, and you see this artificial heart, the Jarvik 7 here, really doesn't look much like the human heart, if you will, but it helps to mimic the function of the heart, because these sections here represent the arteries and veins that carry blood to and from the heart, from the lungs and from the body. Now, this heart is not this artificial heart, the Jarvik 7, is not a replacement for the heart. It's only meant to sustain a person until a donor is found for a heart replacement. And it's only meant to last between 6 months and 2 years. But we actually found that one person actually lived up to 14 years with the heart. So this person was an exception. In 1982, Barney Clark was the first person to receive the Jarvik 7 heart. And since then, there have been more than 350 transplants to date. So Dr. Jarvik has made a significant contribution. And hopefully one day someone will be able to perfect his model so that a person can live with it indefinitely until they actually succumb with the artificial heart and not necessarily need a donor. All right, well, that wraps up that discussion. You have your homework. As always, any questions, email me or see me doing flex or tutorial or ask questions in class. Have a good one.